Yeah, yes. Actually, yesterday we have started what? Just for the recap. Many books. Give me a second. Give me a second. All right. Okay. So yesterday we have studied the self-condensation reaction. Reaction of aldehyde ketone. Right. When you take the aldehyde, right? Sorry, ketone, right? So self-condensation means what? The two aldehyde in presence of the sodium hydroxide, you will end up with the product. Yes, can you all remember? CH3, CO. This is not enough. CH3, CO. Okay, you can write as CH2 again. Yes, OH, CH3, CH2. Can you all remember? Yesterday we studied. And from this, when you use acid with water, acid with heat, give me a second. Sorry. Acid with heat, you will face with what? The dehydration. That what? It's removal of the OH group here and hydrogen from this carbon. So you will end up with the elimination product. CH3, carbon, CH3, double bond, CH, CO, CH. So this is one reaction we have studied, the self-condensation reaction. And next we studied the reduction of what? Aldehyde and ketone. So when you speak about the reduction of the aldehyde and ketone, when you reduce the aldehyde by using the lithium bromide, lithium aluminium hydride, or sodium borohydride, we reduced, you will end up with primary alcohol. And the ketone is reduced to right secondary alcohol. Here we are using what? Lithium aluminium hydride in presence of ether. 1, 2, H plus H2O. Or you can use, yes, sodium borohydride in presence of methanol. So when you want to reduce the aldehyde ketone, I couldn't write it. Alcohol, we need this reagent. But next, if you want to reduce the aldehyde ketone into what? Yes. Hydrocarbons. So what is that? We are using the Clemmensen reduction reaction. So the Clemmensen reduction reaction, we are using zinc in presence of the mercury with conc hydrochloric acid. Then here the CO group reduced to CH2. Are you all clear? This is what we studied yesterday. So today we are going to start oxidation of aldehyde. Right? Let's move on to this one. So are you all clear yesterday's session? Yes?
Yes, Miss.
Clear, right? Yesterday's session?
Yeah.
Thank you. So let's move on to what oxidation of, this is what the last chapter of aldehyde ketones. So I'll just start. So oxidation of aldehyde. Actually, so when we speak about the oxidation of aldehydes, we are talking about only aldehyde, the ketone never undergo for the oxidation reaction. Right? So ketone never undergo for the oxidation reaction. When you speak about the oxidation reaction, we are speaking with only the aldehyde, not with the ketone. So what is happening first? So can you say what are the oxidizing reagent that we have used? Anyone? Anyone, can you remember the oxidizing reagent that we have used? You all are
Sodium
studying.
sodium hydroxide.
Oxidizing reagent sodium hydroxide. We have studied in alcohol. We have done in what? Benzene and everything. Still, oxidizing reagent sodium
OH minus.
Aluminum chloride.
KMNO. Oh,
Yeah, potassium permanganate in
Yeah.
presence of the acidic medium. There is no base.
யாருக்குமே தெரியும்.
யாருக்குமே தெரியும். Finally, I also will go like a man. Because of you all. Okay, I forgot what I said. Okay, so the aldehyde, when you use the oxidizing reagent, it will end up with carboxylic acid. So what should be the oxidizing reagent? Acidic medium, that word should not be forgotten by you all. Permanganate, potassium permanganate. Yes, H plus, potassium dichromate. And what should be other? So here acidified chromic acid also they are using. Potassium dichromate, yes. The chromic acid also they are using. H plus CrO2. These are the oxidizing agents. Either, so any one of three, right? Which is react with your aldehyde, ultimately it will be oxidized to carboxylic acid. Not only this. These are the oxidizing reagent. Along with, we are going to use the mild reagent also. That is what? Oxidizing. The mild oxidizing reagent, Tollens. Right? Tollens reagent. Simply we can say the mirror image reagent and the valence reagent. VALENCES reagent. Actually, these two are, this is the mild oxidizing reagent. We are using to identify these all oxidizing agent also, identification of what? Aldehyde. As you can use as the confirmation test for the aldehyde. I'll say what? It will give the clear observation. The discoloration, the transformation of the color, the formation of the precipitate, right? And the formation of the mirror. Silver clover, right? Okay, the confirmation test of aldehyde. So these oxidation of aldehydes are very important. If you want to confirm whether a compound A is aldehyde, oh, sorry, aldehyde or ketone. Though these all are will give the same reaction in everything, but only the oxidation, the aldehyde will undergo the oxidation of ketone. By using that reagent, you can clearly say that compound is containing only aldehyde. Why? When you say the carbonyl group Cu, both are having the carbonyl group. So how would you determine whether it is aldehyde or ketone? By using this oxidation reagent. Right? You can use one of these reagent, oxidizing reagent or mild oxidizing reagent. We will talk about these two reactions one by one with a clear explanation. And here, actually we said, when you use the aldehyde, you will end up with the carboxylic acid group. But when you use this mild reagent, you will be end up with what? This is base. Okay, it's a kind of the very mild base. So therefore, they are able to form carboxylic, carboxylic acid, not salt of carboxylic acid, salt of carboxylic acid. Are you all clear? Did you all understand the intro part? Did you all understand?
Miss,
Shall I recall again?
okay.
Right. Then you will be clear, right? Wait, I'll use another. Okay, yellow. Actually, when you speak about the oxidation of the aldehyde here, we are not speaking about the ketone. Why? The ketones are not oxidized by using these reagents, right? So, if you want to determine, so the oxidation reaction is the conformation state or step of what? The aldehydes. So, whether your compound A is containing its aldehyde or ketone, why? It's having the carbonyl group. The carbonyl group identification can be confirmed by 2,4-DNP Brady reagent that able to produce the yellow or orange color precipitation if you have the carbonyl group, right? Okay. So how can you say that compound have aldehyde or ketone? That is the clear identification can be done by your oxidation reaction. By using one of these oxidizing reagent, it's clearly visible. And also there is a mild oxidizing reagent that is based on what? The base, okay? That is, one is the Tollens reagent, another one is the Fehling reagent. Actually, when you oxidize the aldehyde, you will end up with the carboxylic acid. But once you use the mild oxidizing reagent, you will end up with what? The salt of the carboxylic acid. Are you all clear? Whenever I say about the oxidizing reagent, guys, you should be able to say these three first. And the confirmation and for the aldehyde, simply we are speaking about the tolerance and the Fehlings, which is very clear visualization. The tolerance is able to form the silver mirror image precipitation. The Fehlings is able to form the color transformation. Right? So from that, you can simply say whether that compound containing aldehyde or ketone or other compound. Yeah. Okay. So again, I'm just imagine you are having compound A. Can you see this yellow color? No, right? They are telling you are having the compound A. The compound A is giving the observation for what? When you use 2,4-DNT, variation, right? Yellow or orange, right? Next, when you perform, okay, you will say the tolerance creation. It gave the silver mirror in testing. Still, I didn't talk about this example. That means it's activated the Dolan reagent, right? Okay. Can you say what is the compound A? So simply, the Brady reagent will give the observation for what? If your compound A is containing the carbonyl carbon Cu, this Brady reagent will give yellow orange color. So definitely your compound is containing what? The carbonyl. And now you have to check whether this is aldehyde or ketone. Yes, ketone never undergo for the oxidation reaction. Only the aldehyde will go. Where the tolerance can give the silver mirror in test tube, that means your compound A is aldehyde. A simple identity. Did you all understand, guys? Is it clear? Okay. And I have sent a message, okay, tomorrow you are having the class. As usual, this week we have done more than 7 hours. Because usually I'm doing the 2 hour tour. So Monday we done 2 hours. Today 2 hours. Yesterday 1/2 an hour. So almost tomorrow if I done the 2 hours, that means you are not supposed to do the Friday session. No Friday session. So tomorrow, as usual, 9:45 to I'm just making as 11:40. No, you can have only 11:15, right? Why? You have the class, so 1/2 an hour session. So within the 1/2 an hour session, we can complete the fortnight exam paper. If we have the time, I will start carboxylic acid also. Right? So that means Friday you don't have the session. Inshallah, I will upload the paper. That is fortnight examination paper Saturday or Sunday. Please submit the answer. I will give 1 or 2 days. Please, not 1 or 2 days, the same day or the next day. Please submit the answer. Right? Okay? Are you all clear? So before circulate those things, I will send a message, and I already forward the message. What about the tomorrow session, Thursday session? And I forgot, I put as 11:45. Sorry guys, we have the class at 11:30. Therefore, it should be up to 11:15. Are you all clear? Okay, right. Let's we move on to the reaction. Okay, the first reaction is oxidation by Tollens reagent. So I said, when I speak about the Tollens reagent, so it simply says what? Mirror, right? Silver mirror in the test tubes. The tolerance, it speaks what? The formation of the silver mirror in your test tubes. So this is what practically we are performing at practical session. Give me a second. Today I will. I can play the video right in Zoom also. Okay. After I complete the tolerance reagent and the peeling session, if I have the time, inshallah, I will share the video and just go through that video. Okay, so let's redo. The first thing is what is happening. The tolerance reagent is containing the Ag plus. That is the concept. The tolerance reagent is containing the Ag plus. This is what you end up with the tolerance. Containing the Ag plus, silver, iron. So in the form of what? So you have the Ag plus. You can see as that is in a complex ion, a silver ammonia. Right? Okay. So what is happening during this oxidation of the aldehydes? What is actually happening in here? Aldehydes oxidize to carboxylic acid, right? Definitely I said this is a mild oxidation route, so you will end up with the salt of the carboxylic acid. Should be very careful. Right? Here the iron, this Ag plus is there. You have the Ag plus, right? We are using the tolerance reagent. You have the Ag plus here. The Ag plus reduced to Ag as a silver, which will deposit in your wall of the test tube. Did you all understand? If you see the video, it will be a little bit clear. Did you all understand? Is it clear? Again, I'm just telling you, your tolerance reagent is containing what? The Ag plus ion in the form of this ionic formation. When I said the aldehyde subject to the tolerance reagent, it's oxidized to carboxylic acid. You can say the salt of the carboxylic acid. Actually, your tolerance reagent containing what? The Ag plus ion in the form of this ion, right? This complex. So what is happening? This Ag plus positive ion is reduced to what? The Ag as a silver mirror. That's what you can see in your test tube wall, right? As a silver mirror deposition. Are you all clear now? I have to write the reaction. If you understand only, I can speak about that. Is it
Yes.
clear?
Yes.
And actually, this reaction is what I already said. The tolerance reagent which is used to distinguish the ketone and aldehyde. I already said that, right? Okay. So let's write the reaction before 5 minutes. We will finish the reaction. So what is the reaction? Actually, I said when you speak about the aldehyde, let's write the aldehyde. RCOH. Yes, reacting with what? The tolerance reagent. What is the composition of the tolerance reagent? Ag, NH3 twice, right? In presence of the basic medium, they are using the sodium hydroxide here. And ultimately, you will end up with carboxylic salt of the carboxylic acid. That means not OH, O minus. The production of the ammonia and the deposition of the silver mirror with the water. So let's rebalance the equation, right? So according to that, you will have the 2. This is as a 3. 2. 4. Actually, what is your observation is here. This is the silver mirror deposition. Are you all clear? When you use the aldehyde, the presence of the tolerance reagent, Okay, with tolerance-free agent, in presence of the base, you will end up with the salt of carboxylic acid. In production of the ammonia, the objective is you can observe the silver mirror. This is what explains the oxidation of the aldehyde by the tolerance-free agent. Are you all clear? Are you all clear? Clear? Fine? Okay? So next, say okay, then only I can go for next. Is it okay? Hello?
Yes, please.
Okay, right. So this is what the tolerance-free agent. And next we are going to speak about what? The oxidation by the failing solution. Oxidation by failing solution. So earlier we talked about the tolerance-free agent. That is what the composition of silver ion. Here the failing solution having what the copper 2 tartarate ion. That is it. Right? The failing solution containing, right? What is your failing solution? This is the important one. We are having the copper 2 tartarate. Copper 2. Very important, we have to by heart, right? Tartarate. Copper 2 tartarate, right? We are using in sodium hydroxide, basic medium. This composition we are telling known as the failing solution. Actually, what is happening now? The time will be over, guys. Again, rejoin the class, and I will say what's happening here, right? Still, that is there.